especially now, if I make a video and I'm wrong about something, I'll never hear the end of it.
Hello and welcome to another exciting episode of the Being an Engineer podcast. Joining us today is Dean Odell, a seasoned mechanical engineering educator and consultant specializing in GD&T and CMM technologies. With a strong academic background and a popular YouTube channel that educates thousands, Dean brings a wealth of knowledge and experience to our discussion on precision in engineering and manufacturing. Dean, thanks so much for being with us today.
Yeah, thank you so much.
So let's get to know you a little bit. Tell us about why you decided to become an engineer, and then how your focus eventually shifted to GD&T and CMM, coordinate measurement machines.
Sure. So I kind of backed into going to college and stuff. I really wanted to just use up the rest of my GI Bill. I was working as a welder at the time, and my company was getting more into machining, so I wanted to learn about machining at our local community college. And I got confused about the names of the programs, so I signed up for mechanical engineering technology. And I found out afterward there was an advanced manufacturing technology program that was just machining, which is what I meant to sign up for. So I did 2 years of that while I was working as a welder. I had some background as a machinist apprentice. And that was, I want to be clear, that was the title. It wasn't a state-sponsored machinist apprentice program, but I had worked in the trades for a while. And like I said, I had about 2 years of GI Bill left over. So I was like, let me go to this community college and, use that up. And that kind of just went from there. After that, I have to remember now. I was hired as a mechanical designer, and right after I finished my 4-year degree, and I did that for a while, and then I was hired on to where I work now at the college, same college I went to.
Terrific. Okay, and tell the listeners a little bit about what you're doing now at the college.
So I'm a full-time instructor. At that advanced manufacturing technology program I mentioned, that's what I teach in now. So I teach, aspiring CNC machinists mostly. I occasionally have a class in another program, but that's the majority of my work. Mostly print reading, GD&T, CAD, metallurgy, those kinds of subjects. I kind of specialize in those for our trade students.
All right. I have a question for you about GD&T and machinists. I'll be honest, we don't know GD&T super well at Pipeline. I think like a lot of engineering places, environments, we understand the basics. We can put a few GD&T symbols up on a drawing here and there, but we're definitely not experts the way some people really are. For example, you. And occasionally, someone on the team will suggest, hey, we should really get some GD&T training. And someone else, this is the objection that I always hear, not just from Pipeline, but from plenty of other engineering companies as well. The objection is, well, we could do that, but most machine shops don't even know how to read GD&T. So right. What's the point? I'd love to hear just your general opinion or thoughts about that.
Right. I've heard that a million times as well. And it's just one of those things. It just depends. I mean, good machine shops will understand GD&T just fine. Anybody doing high-end work for defense contractors or medical device industry or aerospace, they know GD&T perfectly good. People are picking it up more and more as time goes on, but I've heard that. And, part of it is the customer's always right. If you go to a shop and they're going to triple the prices if they see a composite position. If that's your only choice, you might have to pull the GD&T off the drawing. And, as I'm sure we'll talk about later, GD&T is about design intent. So as long as the machine shop doesn't necessarily need to know the ins and outs of every single symbol. It's really, can they make the part correct? And then can it be inspected to the GD&T?
So that's a really great point. Let's just dive right into that now. what, at a high level, at its most basic conceptual level, what is geometric dimensioning and tolerancing, and why does it exist?
So GD&T is, a language, and that's in the first page of every GD&T book. But it's really a language to simplify things. Before GD&T, so I have a drafting manual from General Motors from the 1950s. When they wanted to apply a geometric concept like perpendicularity, they would do it with a note. So it would say, hey, this surface needs to be perpendicular to this surface within this number. And for, say, coaxiality, that would be a note, and they'd have to write all this stuff out. And, writing it out leads to problems. I'm sure you're very familiar with drawing notes. You keep them very short because the longer you go, the more issues you can have. So early GD&T was just replacing these concepts that they're doing in machine shops anyway. One of them is run out, right? So the surface variation relative to axis of revolution. Every machine shop that makes round things is doing that. It's just putting it into a symbolic form that saves space on the drawing, because that was a thing back then, right? Everything was done by hand, and standardizing it. So you go to Y14.5, see what the definition for that symbol is, and kind of go from there.
That's fascinating. I didn't know the history behind GD&T, that they originated as drawing notes, and the symbols were just a way to make it faster to communicate on a drawing.
Yep.
Very cool.
Yep. And it's grown over the years. Early GD&T, there's just a couple symbols. And, it's up to, it was 14, and now it's 12. They took 2 away. But, it just grows every 10 years. They do a revision. The standards get longer and longer and longer.
Well, it's nice to hear that they're taking some things away as well. I think all of us can get trapped in that routine where we're just adding, and then whatever it is we're working on grows to be unwieldy and giant. So it's nice to hear that they're pruning things also, being so thoughtful about it.
Right. Yeah. 2 commonly misused, concentricity and symmetry, were pulled out of the standard. Now, I'm not privy to the committee's decision making, but it seems pretty clear that they just got sick of people misusing them, and they took them away.
All right. Let's talk a little bit about your YouTube channel, which has grown over the years and has a really impressive following now. You have lots of subscribers, and at least dozens, if not hundreds, of videos out there, mostly about GD&T. How did the channel get started? What was the impetus for beginning that? And how has it grown over the years? And what impact have you seen it have on engineering education?
So the first video I ever made, it's still up there, was like December 2018. And I was just a part-time instructor. And it was just kind of goofing around. And, I made a couple videos before the pandemic, but not really seriously, because it didn't really matter. Once the pandemic happened, I decided to go fully online. And because of my experience in college, I really didn't like classes where you're presented with all this stuff to read, and just, here's a PowerPoint presentation, flip through it and write what you think about it, that kind of thing. So I wanted everything to be video. Every lecture I used to do in person, I wanted to be on video. So, with limited success in 2020, I got that started. And then by 2021, 2022, I started to kind of fill out all the videos I needed for my classes. GD&T is by far the most popular, and I have the most videos about it, but there's also videos on industrial relations, safety and health, and manufacturing processes, and a couple other classes that I teach. So as far as, making the channel, it's an incremental process. If you go through and flip through old videos, I tried all sorts of different things, all different techniques for reading off a script or not reading off a script. I did a lot of videos just sitting in front of a camera, and moved to a whiteboard. The feedback from YouTube has been pretty good. The first couple years, nobody really comments, but now it's, I get like 10 a day I have to kind of read through, and I do read them. Sometimes people have useful information, not usually about the technical aspects of the video making. That I kind of have to figure out myself. They will let you know if the sound is bad, or especially, oh my God, the background music. People will let you know they hate that, but I like it. So they got to tough it out,
Did you expect the channel to do so well, or was that just a pleasant surprise?
No, I had no idea. I've liked YouTube forever. I think it's just such a great thing to be able to listen and learn, and it's got music on there. It's got everything. And I never saw myself as like a YouTuber. But once, there's a niche for GD&T that I kind of saw that I could fill, when I was trying to learn it. The videos were very few and far between. So I kind of set out to make a complete, free course where people could learn it, from YouTube. It's just like any other subject. I had a dynamics class, engineering dynamics, with a horrible instructor who just was a first time teacher. He just wasn't a great class, but I learned most of it off YouTube, for studying for tests and everything. And I'm grateful to that guy on YouTube that made those videos forever. That's how I learned everything in that course.
Yeah. What, I know this happened during COVID where online was really important. Was there anything else that compelled you to do this? Because it takes a lot of time to create these videos. It's not like you just snap your fingers and there they are. Or was it really just COVID and you needed a way to still teach your students, and that was online was the only way?
Yeah, at first it was just, hey, I want to, make this for the pandemic and everything. But after I started doing it, I realized I was kind of good at it. So I just kept on. I mean, I could have stopped at a certain point and said, hey, I have videos for all my classes. I'm done. But yeah, I do enjoy the ecosystem, getting that feedback. And, I made a lot of videos about GD&T before I ever went and got the senior certification. It really helped me to study, to make these videos, and it's helped me understand GD&T on a much deeper level, because especially now, if I make a video and I'm wrong about something, I'll never hear the end of it. I've got really cool people that will email me or DM me and say, hey, I think you made a mistake here. I don't want to publicly comment. But it's kind of a nightmare if I get something wrong. So I've got to be more careful than I used to be in older videos, where I could kind of spitball a little bit more.
Yeah. Well, something else that has changed over the course of your video career is the hair. You had some sweet long hair before, and you look great now with short hair as well. But I just want to put it out there that I love the long hair, and I'm putting my vote in for a comeback of that long hair.
Oh, thank you. Yeah, that was oh man, YouTube comments are 99.9% positive. The really nasty ones were about the hair.
Really?
Yeah. Oh man, people would say awful stuff, and I delete and block them. I'm not a free speech person on my YouTube comments.
Yeah.
But yeah, thank you. I really enjoyed it. I had a guy that was going to make me a logo for free, and it was the hair or whatever.
Yeah.
And I had to be like, I'm going to cut it eventually, so I don't want to make it like where I have to have it forever.
Well, not that it really matters one way or another, but I was a fan.
Thank
of
you.
The long hair. I thought that looked really cool. All right. What are some of the most common misconceptions that students and maybe even practicing engineers have about GD&T?
Well, they think it makes things expensive. They think it's unnecessary. They think, I don't want to say it's too hard to learn, but maybe from an engineering perspective, it's like, hey, we didn't cover that at my university, so how important could it be? We covered calculus. That was important enough to cover. We covered fluid mechanics. If we didn't cover GD&T, do I really need it to do engineering? I think that is
comments about that.
Yeah.
I use probably 10% of what I learned in school on the job.
Right.
And the other 90% are things that I learned after I graduated that were never taught in college, not the least of which is communication and getting along with people and organization, things like that. Although I will say at my university, we did cover GD&T. There was a course for GD&T as well.
And I will give universities a break. You can learn GD&T on the job. You can't necessarily learn differential equations on the job. So there are things that are better set in the university environment. GD&T, most people learn it on the job. So yeah, it's doable.
Fair. That's fair. Something else that you have in your lab are a whole bunch of Zeiss CMMs, and they go, hand in hand with GD&T. How did, was that part of the course when you started, or are the CMMs something that you brought, to the table?
So me and my colleague, were instrumental, and we had a couple, and we got a few more in the pandemic, and I think there's 12 in that room now. Yeah, that's a huge part of our program, for machinists being able to inspect things and, more importantly, be able to explain decision making when it comes to metrology, so that when they're getting their parts inspected and a metrologist, tries to sell them a bill of goods, they can fight back. And you only really get that if you know how to program a coordinate measuring machine, which is a very important course for us.
Yeah. Yeah. And, doing inspections on a CMM, it's not necessarily black and white. There's some real training that goes into it to understand how to interpret the drawing, which is what you teach. If I were to use a CMM, chances are I'd probably get a bunch of things wrong. But that's part of your course as well, is teaching students how to use these in the context of, a print that is being inspected.
Right. Yeah, a CMM isn't as simple as just taking what's on the print and punching it in the computer. There's a good bit of interpretation that has to go on, and the data you get. I mean, there's so much you can do with a CMM. You can take touch points, you can scan, you can get 1 million points or 10 points, and it's just huge subject of stuff. And there's so many settings. It's kind of like CAD. There's so many settings in there, and being able to kind of untangle it all can be overwhelming at first. But I think it is an important part of the education of, GD&T and print reading, is being able to take that to the next step. And we were talking about YouTube before. I have a good few videos about that. And I think people really resonate with the inspection part of it, as well as just the whiteboard. Hey, this is what this symbol means.
Going back to the videos, YouTube, what are some of the challenges that you've encountered, and do you have any pro tips for solving the complexities of taking sophisticated technical content and making it, really accessible over a video?
So I'll go in the context of the CMM videos I've made. You start from the beginning. So you make a video, hey, how do I turn the machine on? All right. You got to start there. And then a video that's very simple. How do I qualify a probe? And you build just like in the learning process. So in GD&T videos, I'll start with, hey, here's some definitions. Here's the big picture, and then we'll drill down on this, more minute topic. I try to just explain things in videos, basically how I would in a classroom. The video format is great because you can fast forward through things. So if I have an hour-long lecture, the video version would be like 20 minutes, which I think is, I don't know. If I was a student, I would appreciate that, not to have to listen to something for an hour. You just get it compacted into 20 minutes.
You cut out the non-essential parts and just give the people what they need.
Right.
Yeah. Yeah. You also do some consulting. And when you're doing training for a client or a client's team, how do you tailor those in-person sessions to, meet all the different needs that a different company or different teams might have?
So when I do in-person trainings, my style is on a whiteboard, just like the videos. And I've had companies when I show up and they're like, oh, well, here's, the computer you can put your slides on. I'm like, well, I don't have any slides. They give me a look like, oh my God, we hired this guy and he's not prepared at all. Right. But once I start doing the whiteboard thing, I really like that method because doesn't force them. People are inspired to take notes. Whereas with a PowerPoint, people are much less likely to take notes because they're looking at the slide. Maybe they know they'll get a copy of the slide, that they're listening, which is good. But the note taking process is really important for me in an in-person corporate training and whatever conference room they can get for me.
That's an important insight.
Yeah. I found it really, really helpful. And like I said, the first hour or so, people are caught off a little off guard because they're basically back in school. And how I've tried to relate it is go back to college, you would never take a Calculus 1 class where they're just putting PowerPoint slides on the screen, right? Your instructor is going to be on a projector or on a whiteboard solving problems. And that's how I approach GD&T. I don't want to trash PowerPoints because I know for efficiency reasons, other companies use them. And I'm not saying if you're using a PowerPoint, you might be using a whiteboard as well. So I don't want to go that far, but my personal method is just all whiteboard. I draw everything out. I think people get something important from trying to understand what's on the board and get it in their notes. So they're thinking about it on a couple different levels. As far as I'm drawing a figure, putting a symbol on it, they're drawing that in their notes, and then they get to keep their notes and they're done.
Yeah.
And the other thing you mentioned, tailoring, is whatever a company wants. If they say, hey, we don't have any shafts, we don't have round parts, but cool, I won't talk about runout. We'll skip circularity. We'll just talk about the stuff you guys need. It's the GD&T is a system in such a way that there are things you could leave out and still understand, 80, 90% of it.
Terrific. Well, I'm going to take a very short break here and share with everyone that the Being an Engineer podcast is brought to you by Pipeline Design and Engineering, where we don't design pipelines, but we do help companies develop advanced manufacturing processes, automated machines, and custom fixtures, complemented with product design and R&D services. Learn more at teampipeline.us. And the podcast is also sponsored by The Wave, an online platform of free tools, education, and community for engineers. You can learn more at thewave.engineer. And we're speaking with Dean Odell today. And speaking of The Wave, one of the big events that The Wave sponsors is PDX, which is coming up in October, the Product Development Expo. And we are so happy that Dean is going to be joining us there as one of our training partners. Dean, maybe you can just take a few seconds and talk a little bit about what you have in store for PDX, or just general thoughts, or maybe you have questions for the eventual attendees for your training session, and you want to solicit feedback. But any thoughts or anything that you want to share there in regards to PDX?
Sure. Yeah, I'll be there. I'll go get a whiteboard from Staples, and I'll teach things basically how I normally do. I'm open to if your audience has any suggestions. It'd be my first time doing that kind of thing, outside of a classroom, but I can talk GD&T all day. So if I have to put a sign on front that says, debate me, we can talk about whatever topic, anybody would like to discuss.
And you don't need any slides. It's all up there in Dean's brain.
Yep.
Nice. If you mentioned that there's a committee who every decade or so, they make changes to GD&T. They add things, they clarify things, maybe they remove things on occasion. If you were part of that committee, what changes to GD&T would you make?
Oh, that's interesting. I could get in trouble for this one. I would seek to simplify things by removing symbols. And again, I'll get in trouble for this, but I think circularity is could be replaced by something else. There are certain symbols that are very easy to use, but it's hard to explain. Don't make a lot of sense. So flat, well, I don't want to say flat. Perpendicularity, circularity, flatness. I could show that symbol to anybody and they'd instantly understand on a logical level what it does. And I think what happens is people who aren't experienced with GD&T will kind of use those too much where they don't make sense. So they'll see a hole and say, well, the only thing I know about my toolkit is circularity because it's obvious, or cylindricity, and they'll put it on the drawing. So I would reduce some of the symbols and use profile for more things. And yeah, I would try to reduce the page count. It's gotten very, very long. And I know a lot of people work very hard on that. So I'm not saying their work is not good. I just think if there's any possible way to reduce the page count a little bit, so it's a little bit easier, less unwieldy, I think that would be good.
I don't know what year it was published. It's definitely out of date right now, but probably most of it is still applicable. I have a scanned copy of a GD&T pocketbook, and it's awesome. It's like, I don't know, 15 pages or something. And it's just like a really concise summary with a couple of basic examples of all the different GD&T concepts. And I love that thing. I'll go back to that thing, over and over before opening up a Bible full of way more content than I ever want to go through on my own. Do you have any favorite GD&T concepts?
Yeah, profile. Profile can basically be used for everything. And the way I teach GD&T, I basically start with profile and explain how it can be used to control flatness, perpendicularity, parallelism, all that stuff. I think it really helps people to understand GD&T as a system, to see how profile, depending on your datum references, basic dimension, plus or minus dimension, how it would control form, size, location, and orientation in different ways. So conceptually, I think that's a good way to learn the system. And after you have profile, you don't really need anything else. And you can make an argument that position is a very special thing. And well, I'm not saying you could replace position with profile. Position and profile, you have to have both. But you could essentially replace run out with profile. There's new dynamic profile. Allows you to do some things you weren't able to before. So yeah, that would be my go-to. If I had to teach GD&T in 4 hours, I would do datums, profile, and position. And I could get people on the right track. Great.
Okay. I had a question that I just lost. What was it? We were talking about, your favorite GD&T concepts. Darn, I've lost it. I'll have to come back to it. This might be the same. Well, it is the same, because I was going to ask you if you could only teach one GD&T concept, which would it be? And you already said it'd be profile, datums, and was it position? Is that what you said? Okay. What are some of the most commonly used GD&T concepts, and in your experience, should they be so commonly used?
Oh, interesting. So I think what you see on most drawings is position. Position for holes and cylinders, things like that. I think that's what people think about first. They think about position, bonus tolerance, that kind of thing. The next would probably be flatness. You see a lot on drawings if it's a kind of rectangular part, perpendicularity, and that's all in qualifying a datum reference frame. For round parts, it's going to be a lot of run out generally if it's a part that spins. And as far as, use, overuse, I think I touched on that before. For people that aren't familiar with GD&T, every flat surface, you might say, well, I gotta put a flatness on it, right? I want it to be flat. And that goes back to understanding the concept. So, rule number 1 is a concept that links size and form. So essentially, if you have a plus or minus dimension on a rectangle, the form of both sides is already controlled. And that's why GD&T training is rather important, because if you skip that and just go straight to the symbols, you can kind of land in some hot water, because you end up overusing symbols that aren't really necessary.
The Product Development Expo, or PDX, is your chance to learn from subject matter experts providing practical, hands-on training for dozens of different engineering topics. GD&T, Advanced Surface Modeling, DFM, Plating and Finishing Techniques, Programming Robots, Adhesive Dispensing, Prototyping Tips and Tricks, and lots more. PDX happens October 21st and 22nd in Phoenix, Arizona. Learn more at pdexpo.engineer. That's pdexpo.engineer.
Going back to the fundamentals of GD&T, what can an engineer do with this tool, with GD&T, that they can't do with just standard tolerancing, like you're 8 inches plus or minus 0.2 inches, right?
Right. That's a great question. So they can get their design intent across. You may have seen a composite position control frame. It's the one where there's one symbol and 2 tolerances, right? It's the complicated, scary looking one. What an engineer can do with that, and the example I always use is a light switch on a wall. You can control the two holes to each other separately from where the two holes are relative to the floor. So if you have a pattern of holes in any part, you can control things separately, and you can put that on the drawing. You're basically saying those two holes need to be a certain distance from each other, but they can be a larger distance as a pattern from the floor. And that's something that would be super complicated to do with a note.
Got it. Okay, great. What is it that compels you to continue developing all of your educational content and mentoring the next generation of engineers? What do you think it is that motivates you?
So I've gotten this question before. I'm not sure about mentoring the next generation, but as far as making the content, I'm just good at it. You know, when you find something you're good at, you want to do it.
Good.
Yeah, you want to do it more. There's obviously a need for this, so I just kind of, keep going with it. And obviously I enjoy it. I've got, your viewers can't see, but I got this from eBay. I'll read it. Drawings and Drafting Room Practice 1946 as a book from, I've had a search for it on eBay for years. When you type it in, you say, let me know if this popped up. I bought it within minutes. I bet that seller was like, I thought that, you know what I mean? You sell some random thing. So yeah, I'm pretty deep in the game, as far as GD&T and all that goes. But yeah, I genuinely enjoy it, and I happen to be good at it. I think I'm a good teacher. I'm not sure about a mentor, but I think I can teach pretty well. So that's basically it.
Well, when you have GD&T or any kind of dimensioning and tolerancing on a drawing, of course, that only matters to the extent that someone can measure it afterwards. What are the most common tools for inspecting a part based on the GD&T or the basic dimensions and tolerances in a print?
So, measuring things on a plate, and I've got a couple videos about this. Your best friend is a height gauge. And it's one of those things that there's not very much information about as far as textbooks or reference materials. You basically have to have somebody show you how stuff works. And I'm no expert at plate inspection, but you got to have somebody show you, hey, you use, this gate or this angle block to hold the part. So you present it parallel to the height gauge so you can sweep it. It's just something you wouldn't see if you just walked up to that equipment. It really is like a puzzle, as far as all the 1, 2, 3 blocks and angle blocks and your height gauge. Like, where do I even start? So I find that really interesting. And a lot of shops still have that equipment. And a lot of times you'll hear arguments. And you've probably heard this before. I measured it in the CMM and got this number, measured it with a gauge pen and got this number, who's right? So I find those arguments very interesting. And that goes back to Y14.5 and GD&T. And shout out, there's 2 other Y14.5 standards. Y14.45 is the data measurement reporting standard. It's rather new, 2021. And Y14.43 is the gauging standard, which has these awesome illustrations of gauges for GD&T. I think those are both really good resources if you are, in the measurement game and you want like the official source on how this stuff is supposed to work. Now, for your audience, it doesn't tell you how to measure stuff. That is like the white whale as far as some book that shows you how to measure everything. Because as I mentioned, everything is its own puzzle, right? Nothing is going to be, there's no standardized way to measure the position of a hole. Some parts are easier than others, but you kind of got to come up with it on the fly.
How much does a decent height gauge cost?
Oh, not much. You get them on eBay for $50.
That's it?
Yeah. I wouldn't say calibrated or anything, but as far as, one that's calibrated, a couple $100 maybe. They're not that expensive.
Yeah. All right, Dean, I've got an idea for you. I think that would make for an amazing training session at PDX if you had a height gauge, and you showed attendees how to measure their parts. I mean, attendees could even bring some of their parts with them to the event, and you could show them in real time in person, this is how I would go about using a height gauge to measure this. Because, I mean, a CMM, most companies don't have $500,000 lying around to buy a CMM. But, a few $100s, if you can get a height gauge and maybe a granite block, right? That becomes much more accessible. And actually, as I've interviewed people, attendees for PDX, one of the things that they have specifically asked about is, how do we do inspection without a CMM?
Really?
And this would just be, I think that'd be a really cool training session.
Yeah. So, I know it's an audio podcast, but I'm showing here, this is my little granite plate that I use for virtual trainings, the little height gauge. So yeah, that's something I could do. I could see what UPS is going to get me for mailing a granite plate. Maybe I'll go to Home Depot to get some linoleum.
Yeah. Or if you can't find anything easy, I have a feeling that I know a company that could lend you a granite block for the event.
Okay. Yeah, that's something I could definitely do. I really like in training to use real tools.
Yeah.
I don't like wooden, height gauges. The real ones are not that expensive, especially for training purposes. It could be beat up. It doesn't matter. But a lot of people, go to university, college, they never see one of these things, or they walk by it, but they don't know how to use it. So yeah, that's something I could definitely do.
Terrific. Yeah. Terrific. All right. Well, Dean, anything else that you'd like to talk about or share before we end this interview?
No, I think I'm all set.
Okay. Well, thank you so much again for being on the show, and super excited to meet you in person later this year at PDX.
Awesome.
I'm Aaron Moncur, founder of Pipeline Design and Engineering. If you liked what you heard today, please share the episode. To learn how your team can leverage our team's expertise developing advanced manufacturing processes, automated machines, and custom fixtures, complemented with product design and R&D services, visit us at teampipeline.us. To join a vibrant community of engineers online, visit thewave.engineer. Thank you for listening.